Hi, we are Group 1 from Database Practical Group 14, and today we were talking about our database assignment, which we choose our topic as Wildlife Sanctuary and ours is known as SunwayWildHaven. This is a definition for SunwayWildHaven, and SunwayWildHaven is a non-profit organization dedicated to wildlife conservation. Our main goal is to design a relational database system that helps SunwayWildHaven efficiently manage and track various aspects of their operations. This includes managing animal records, veterinary care, staff and volunteer tasks, donations, and feeding schedules. Our system aims to help with the following things. First, we have streamlined operations. By automating record keeping for animals, enclosures, medical cares, and tasks, the system will increase productivity and minimize the risk of errors. Next is to enhance animals' welfare. Our system will ensure that every animal is properly housed, receive required medical care, and are fed according to their specific needs. Following, we have support, volunteer, and staff management. Our system will make it easier to assign tasks, track progress, and recognize the contributions of staff, volunteers, and staff. Lastly, we have ensure transparency in donations. Our system will provide clear records of donations, making it easier for SunwayWildHaven to report to donors and track funding for operations. Now, for our business rules, first we have animal enclosure. Each animal must be assigned to one enclosure at a time. Their movement history will be recorded to support welfare tracking. This is to ensure that every animal has been assigned. And next, we have task assignment. Staff and volunteers can have multiple tasks, but only one per task to avoid duplication. This is to avoid task duplication. Next, we have medical records. Every animal must have at least one checkup recorded by a registered vet to ensure proper health monitoring. This is to ensure that every animal has at least one medical record. And next, we have enclosure limits. Enclosures cannot exceed their max capacity. The system must check this before adding new animals. This is to prevent overcrowding. And lastly, we have donations. All donations must have a valid name, a minimum of RM10, and a specific type of enclosure, proper tracking and reporting. This is to ensure that every donation is legitimate and useful so that we can track their contributions and transparency. That's all for me.
So this is our ERD diagram covering key entities like animals, which has animal ID as its primary key, medical record ID, and enclosure ID as its foreign key. Enclosure entity has enclosure ID as its primary key. Medical record entity has medical record ID as the primary key, and animal ID and vet ID as the foreign key. Vet entity has vet ID as its primary key. Enclosure movement entity has a movement ID as its primary key and animal ID as the foreign key. As for the feeding schedule entity, has primary key of feeding ID and foreign key of animal ID, volunteer ID, and staff ID. Volunteer entity has primary key of volunteer ID. Staff entity has staff ID as the primary key. Task entity has task ID as the primary key. The staff task entity has a composite primary key consisting of task ID and staff ID, and both of these are also foreign keys referencing the task and staff table respectively. Besides that, the volunteer task entity also has a composite primary key consisting of task ID and volunteer ID, and both of these are also foreign keys referencing the task and volunteer table. Lastly, the donation table entity has donation ID as its primary key. And next, I will explain about the relationship between the entities. So first up, each animal is assigned to one enclosure, while one enclosure can house many animals. Next, an animal can have many or no enclosure movement, while an enclosure movement must have at least one or many animals. Next, an animal can have at least one or many medical records, while many medical records can belong to one or many animals. Next, each medical record is written by one vet, while a vet can handle many medical records. Next up, an animal can have one or many feeding schedule, but each feeding schedule is for one animal. Next, a staff member is responsible for one or many feeding schedule, but each feeding schedule is logged under one or many staff. Next, a volunteer may feed one or many animals, but each feeding schedule records refers to only one volunteer. Next, a staff can be done by one or many volunteers, and each volunteer can perform one or many tasks. The volunteer task table links tasks to volunteers and volunteer to a specific task. Next, A task can be done by many or one staff, and each staff can perform one or many tasks. The staff task table links tasks to tables. The staff task table links tasks to staff and staff to a specific task. Lastly, the donation entity is independent. It stores donor information without direct links to other entities.
Hi, I'm member 3 and I'm in charge of the SQL implementation for our project, WildHaven. My task is to demonstrate how we created the core database structure and loaded it with sample data. We start by safely dropping existing tables using execute immediate. This ensures we always begin with a clean environment, especially when testing or making changes. Next, we create the key tables, enclosure, which stores zone and habitat details, vet for veterinary staff, animal, which includes species and closure ID and a reference to medical records. Medical record, which logs checkups and treatment. This table from the core of our sanctuary data model. After creating the tables, we add foreign key constraint and enforce relational integrity. For example, each animal must belong to a valid enclosure. Each medical record must reference an existing animal and vet. Once the structure is in place, we insert the data into each table. For example, enclosure like the savanna exhibit and rainforest habitat, animals such as Leo the lion and Coco the orangutan, medical records linked to those animals and handled by actual vets. We then update the animal table to assign the correct medical record ID to each animal. This simulates the real-world process of assigning a medical history after the animal has been admitted. Finally, we run select queries and confirm that all data was inserted correctly and relationships are intact. This includes checking animal enclosures, vets, and medical records. For the conclusion, this demonstration shows that our SQL implementation is fully functional, with all tables, constraints, and sample data properly aligned with our sanctuary scenario. This structure forms the technical foundation for the queries and analysis you'll see in the next section. Thank you.
Hi, I'm Oscar. So today I will present my part where to demonstrate and explain the constraint used in our SQL implementation. In this database, we apply three types of SQL constraints to ensure the data consistency and reliability. First, we use primary key constraint on all major tables. This is to guarantee every record is unique and identifiable. For example, when ID is the primary key for the when table, and animal ID is the primary key for the animal table. Second, we use foreign key constraint to link the table together and maintain the relationship. For example, the animal table have a foreign key enclosure ID, which refers to the enclosure table. This is to make sure that an animal must be assigned to a valid enclosure. We also have foreign key link for feeding schedule, enclosure movement, task assignment. The last constraint we use is not null constraint. It is to make sure the important fields are always be filled in. For instance, in the when table, the when name cannot be left empty. Also, in the feeding schedule, the feeding that must be always provided. We did not use any constraint type like unique, pair, or default because they were not required in our scenario. They could be considered in our future improvement. For example, it can help to prevent the duplication of email, and restrict the feeding hour. These constraints are critical because they help to enforce the rules in our database and prevent incorrect or incompleted data from being inserted.
Hi, my name is Cha, and now I'll explain the first three queries that we use in this assignment. The first query requires an outer join. Hence, we have created these queries that helps to identify the animals that may not yet have any medical attention by showing all the animals regardless of whether a corresponding medical record exists. This supports compliance with the third business rules, where every animal should eventually have a medical record. The second queries require a minimum 4 table join with a group by function query. Hence, we have these queries that help the management department to have a better understanding about the resources allocation and the feeding costs across different enclosure and species. So consequently, they can have a better budget planning and dietary management strategies. For the third queries, it requires a string pattern matching and a date function query. Hence, we have these queries that help to identify all the recently emitted memos that may need some special attention during their adjustment period. This pattern matching all the memos and the date function queries help in identifying the recently arrival memos for focused care management. And that's all from me. Now I'll pass to Chiu to continue explain the rest of the queries.
Hi, my name is Tio, and now I will explain the left three queries. So the first question is a query having both O and N. This query's purpose is find animal needing attention. This query identify animal that require immediate attention based on multiple criteria. Either they are young or recently admitted, or they are old and have not had recent checkup. This help prioritize veterinary care and monitoring effort. And when we run the code, when we run the query, this become the result. It will have the animal ID, animal name, species, age, emission date, checkup date, enclosure name, and the priority level. From this query, can find out which animals need to have a checkup. Let's go to the next question. A query that consists of at least two sub-query. So this one is find enclosure with above average occupancy and their feeding costs. This query help identify overcrowded enclosure and their associated costs. First sub-query, calculate average of occupancy across all enclosure. Second sub-query, calculate total feeding weight per enclosure. This information is crucial for capacity management and resource allocation. So when we run the code, our zookeepers can see from here the current occupancy got how many, and then the total feeding weight of the enclosure name, like the type of the animal. So let's see our last query list the animals that has been in the sanctuary for over a year and has received the most positive health check rating for health studies. So let's see our last question is list. So let's see our last question. List the animal that has been in the sanctuary for over a year and has received the most positive health check rating for health study. Our first filter is the emission date must greater than the month is 12 months. Ensure only animal that has been in the sanctuary for more than 1 year are included. And we also use the join link animal with medical record to get checkup data. And we also use grouping and count medical checkup per animal. And we also got sub-query find the maximum number of checkup among animal meeting the condition. And the overall we use having to filter only animal whose checkup counts match the maximum most positive health check rating. So let's run the code. So from this one, you can see the animal ID, animal name, emission date, and checkup count. So the emission date will like greater than 12 months, which is more than 1 year. And we can see the checkup count and it show the most positive health check rating for the health study. Yeah, that's all from us. Thank you.